So I've been doing a little more work on the biped enemy. I was going to try to do some of this live on camera today, but my work hours have been sort of disjointed recently, so it ended up sort of being stretched out across the entire day. I figured it would just make more sense to sort of go back and recap everything that I've done today. So before I just start like digging into the implementation and showing how some of this works, both in code and in content, I'm just gonna jump into the game here and show off exactly what I've been working on. So this is the biped enemy. It basically mimics the player's movement, and what I have him doing right now is just walking back and forth. But you'll notice that when he reaches a small ledge, he'll jump up onto it, and when he reaches a wall, he'll stop and turn around and walk back the other direction. And that's all he does. He's just going to keep doing that forever. In fact, if I come here and like go to like 10 times speed, you can see he just does that forever. Because of the delta time there, so you'll notice sometimes he misses the ledge, but you know, in normal gameplay scenarios, I'm not really worried that that would ever happen. So eventually that guy will become player aware, and once he sort of starts pursuing the player, he'll just pursue relentlessly, even if it means like he'll fall into pits and kill himself. So being able to like train enemies into pits will be a valid strategy. But yeah, so that's pretty much what I've been working on today is getting them to recognize, basically have some spatial awareness of their surroundings, so they can jump up onto ledges and stop before they hit a wall. So open up the uh, entity tool here for the biped enemy. Oh, I guess last time I was showing off some editor work. I sort of briefly showed some of this entity tool stuff, but figured for this video I could show a little bit more of how this works. This is sort of like an all-in-one tool for defining animation sets, but also collision for any entity in the game. So like normally, I guess if I'm just starting by creating a new entity, it will by default create an idle animation, which is just like one frame. I automatically set as the initial animation, which means that if nothing else is playing, it always like defaults back to this one. Hi cat, I'm recording a video here. My cat is desperately trying to get my attention. So basically the way this works is you can come in down here. So you'll see. Let me go to one that has multiple frames. So like on the walk animation here, you can see you've got the timeline here. You can click on these and it changes what you have down here. And then in this window, you can click and drag to select the region that you want to use for that frame. And then up in the timeline, you can also click and drag these frames around, so you can reorder those. You have a preview over here. For this walking animation, I have what's called the scrub speed here, which allows the animation to sort of change the rate at which it plays based on how fast the character is moving. Which that's specific to a walking animation. I also use that for when the player is climbing ladders and stuff like that. But for let's go to something else, like just an attack animation. So for this one, it's just 2 frames of animation, drawing back the weapon and then stabbing. And you can see you've got just a little preview over here of how that works. I'm gonna cancel real quick, just to lose those changes to the walk cycle. But yeah, so that's basically the sort of high-level overview. You've got the timeline up here. You can click and drag to select the individual frames. And you can switch those orders around up here too. You can also, in addition to specifying an animation as initial, you can specify that it's a looping animation, so automatically replay when it ends. You can say that something's a jump animation, and what that does is, so for instance for this jump, I have 3 frames, and it will automatically time these frames so that across the space of an entire jump, it will basically play each of these frames with an equal amount of time in between. So I could have any number of frames of animation here, and they would each get an equal distribution of time across an ordinary jump. From starting at ground level, jumping to maximum height, and landing at ground level again. Um, what else do I have here? You can automatically tell it to play another sequence as soon as an animation finishes. So here, like after it plays the attack animation, it automatically goes and plays the cooldown animation, which is just the same, frame of pulling back the weapon. But that sort of has to be a separate thing because at that point, some of the game logic depends on understanding that like when it's in this frame right here, when it's in the cooldown animation, you can go ahead and refire the attack again. Whereas like if it's playing the attack animation itself, you can't do that. So those do sort of have to be split up into two different animations. But then of course you can also specify the duration. You can specify the weight of each frame across the entire duration. So for instance here, this frame has a weight of 1, this frame has a weight of 2, and in this box here, it'll show like what the actual time of each frame is, because the duration of the entire thing is half a second. So then you take the sum of the weights, which would be 3, and this is sort of that fraction of that. I have some generic markup, which I'm not using for anything here, but I can basically mark up. So I can have like actions that take effect when I start or begin the entire animation sequence or an individual frame. Stop when trump, this deals with this priority setting here. So these animations are sorted by priority, which basically when the game is running, any number of animation sequences can be active at a given time. So like the idle sequence is always active, but it should always be low priority, which means that other things are playing on top of it. Whatever the highest priority active animation is, that's the one that is actually rendered on the screen. So this stop when trumped checkbox here means that when something else with a higher priority starts playing, this animation goes ahead and stops. It no longer continues playing, it no longer continues advancing over time. It stops where it is, and usually that also means that it resets to 0. So for instance, with the walk animation, even if it's part way through the walk cycle, it would stop and go back to the beginning. If that box were checked, which is not. I guess that's sort of everything related to animation. You'll notice, I'm not sure how well it's going to show up on the video here, but there's a box sort of visible here, and also this sort of plus or cross in the middle. The plus is the origin. So I can click and drag and move any individual frame around. Like here, I can click and drag that up, and that's just for that one frame. So regardless of how the data is laid out on the sprite sheet here, I can move these around. And that allows me to sort of fine-tune positions per frame, so I don't have to worry about like making sure that every single frame of animation is sized exactly the same or whatever. It can be a little bit flexible. The box here, this is the collision bounds. And if I go to this collision tab here, right now for this character I only have one primitive, but I'll show an example of the player in a second, because the player has another primitive for when they're crouching. But I can click and drag that thing around too, and I believe that is that one's not specified per frame. The collision has an offset, I guess, across the entire scope of the entity. So that one doesn't move around as the entity animates. And then of course I have attachments. I think I did talk a little bit about this in the last video. This is how I would specify, for instance, in the attack animation. I come to this frame where the weapon would appear in the hand, and there's a weapon attachment. And again, I'm not sure if this shows up well in the video, but there's a little thing shown right where the hand is, and that's the attachment point. That's where the weapon gets spawned. And there are some tools here as far as basically specifying the scope of this attachment point. So right now it only exists on this one frame of this one animation sequence, but I could potentially have this attachment point exist across the entire sequence or across all sequences, and that would be useful. I haven't really yet prototyped an example of this, but that would be useful for situations like if I wanted to have armor attachments that so like maybe the player could wear a helmet or something, I could have an attachment point for the head, and say that's scoped to the entire entity. So every single frame of animation on every single animation sequence has an attachment point for a helmet for the head, and that point could be moved around for each frame. So that as the player is walking around and animating in different ways, the helmet could stay attached to wherever the head is drawn for that frame of animation. I guess the closest example I have to that is I prototyped a boss character a while back. They had a weak point, and I was using that same technology for that. So the weak point is something that it's always there, but it can move around, and it's basically it's treated as an attachment that sort of takes damage and transfers damage to the parent entity. This specifies that when I play the melee animation, I query the callback for the entity, which means to figure out what I actually want to spawn in his hand here, the entity is going to provide that data. Hard attach just means it stays fixed in his hand, as opposed to something like a projectile where it spawns and then kind of does its own thing out in the world. This name here isn't actually used right now, but potentially I might want to be able to differentiate various attachments by name, so that's sort of something that I've stubbed out for now. As far as querying the callback for the entity there, I think if I come down here, yeah, it's very, very rudimentary right now, but I have this throw. I have what I call a throw component, or I think actually I've renamed it in native code now. It's called like an attachment informant or something like that. But basically, this is saying that this entity is something that may want to generate attachments. The next entity is going to be sword, and that's a reference to weapon sword entity right here. So it knows that the next thing it wants to spawn in its hand is going to be this thing. So yeah, that's very rudimentary right now. It's just sort of like finding those references by name, but that's roughly the same thing that the player sprite is doing for like the player can actually switch out different weapons, but then also have different secondary weapons. So you can use a throwing knife or an axe, and it uses roughly the same components and technology there to do that some of that stuff. Let's see, is there anything else here? So there's nothing on that scratch tab right now. Collision, I guess, is the last thing. As I was mentioning, actually, I'll show this on the player sprite because I do have some test content there. My player is currently called Stickman because I actually started as, just a stick figure drawing. I never went back and renamed it. At some point, I should do that. So let's see. The player has, a number of animations that the biped enemy does, and, different frames of animation for attacking while in the air. But the player also has two collision primitives. One of these is the default one, and right now these are assumed to be boxes. I do have a way just through markup to define collision primitives that are just a single point for if you want to do a line trace, but within the context of the editor, everything is assumed to be a box. So you have a width and a height there. You can give it a name, checkbox to define whether it's the default, which means that it's active. Things can collide against it. It can collide against things from the get-go as soon as the entity is spawned. And then I have another one called crouch. You'll see this one is 5 pixels shorter. There's some checkboxes up here to say whether this entity will block other things. The player doesn't block things. We want to allow enemies to walk through the player and stuff like that. And then this shallow ledge checkbox. This is I haven't really used it, I think, except in some early test content. But the idea there is if I wanted to treat entities the same way that these sort of ledges are, where you can jump up through them and then hold down and jump to jump down through them, I can treat entities the same way. So in Super Win the Game, I had like platforms that were entities, like the platforms that you would stand on and they would crumble. And I didn't have a way at the time to make those something that you could jump up through or jump down through while you're standing on top of them, and now I do have that ability with that shallow ledge checkbox. But yeah, then so for instance, in the crouch animation here, you'll see like if I switch from walk to crouch, you'll see it does have a smaller collision box there, and that's because over here in the collision tab, I've selected the crouch primitive, and so when I play this animation, then it knows that it needs to switch out the collision primitive for the player to be this one here. And that introduced some problems early in development, where, for instance, if I was standing underneath, or if I was crouching underneath a low ceiling and then I stood up, it would switch back to the taller collision box, but then that would intersect the ceiling and then I would be able to jump through it. There were some problems like that, and I think I've fixed all of those at this point, but it's been a while since I've looked into some of that, so it's possible I might still have some problems there. But yeah, okay, so going back to the biped, getting off of the tangent of the entity tool, I was talking about making the AI be sort of spatially aware and walk back and forth, jump up onto small ledges, and then turn around when it hits a wall. So, I mentioned while I was looking at the collision tab in the entity tool that with markup I could have point primitives for doing line traces, and this is how I would do that. So I just have some markup here that says I have a primitive. I call these trace high and trace low. They are points, so they have no extents, no shape. When I do a trace with them, it's just a single line trace. Some other data here that says like nothing else is supposed to collide against them. They aren't a default primitive for the entity. And then I give these offsets. So the high trace, this is 8 pixels up from the origin. Low trace is 8 pixels down. These are what I use to tell whether there is a ledge in front of us or whether there's a wall in front of us. Basically, I do 2 traces, one from above the waist, one from below the waist, and see if those collide against anything, see how much distance there is before they collide against something, and based on the results I get back from those, I decide whether I want to continue walking forward, whether I want to jump, or whether I want to stop and turn around. Alright, let's see. I already covered a lot of what these components do in a previous video, so in this time I'm just going to go down to the AI component here. A lot of this I've commented out where I had some behaviors for doing various things, and mostly what I'm going to be looking at today is in this giant block here that's all one really gross, overly large behavior, but yeah, everything here is sort of what I'm looking at today. So basically what this says is we look to see if there's anything sort of above the waist, a certain distance in front of us. If there is, we assume we cannot walk forward and we stop and turn around. If we're clear high, then we check, see if we're clear low. If we're clear low, then we can walk forward. If we're not clear low, then we jump forward. So the way we do this, and this is where stuff gets a little bit sort of gross and hard-coded, and at some point I want to go back and make this a little bit cleaner, but this is what I have right now. What we do first is we set the name of the trace primitive that we want to use for testing the distance to a wall to trace high, which was one of the names of a primitive that we specified above. Then we save off a piece of data, and this is just an arbitrary name here, high dist. And we set the value of high dist to dist to wall. Now this is a hard-coded name, and if I switch over to native code here, basically I have this function that will sort of either look up, it can return a value from a literal. So if I just have like a number in there like 50, it will return that from a string. But then also it can look up named variables on the data component for that entity. But then also in certain cases I use strings that have hard-coded logic, and this is one of those, dist to wall. And what this does is given let's see, back here where we said we wanted to call this thing, we have this datum called trace primitive, and we give it this name trace high. Here in code, we look for a datum called trace primitive. We look up a collision primitive with that name, and then we do a trace forward using that. The distance of the trace is currently hard-coded to 256 pixels, which is, again, very, very rudimentary. I need to go back and clean that up at some point, but, you know, I'm just trying to get stuff working for right now. So we do a trace forward for 256 pixels. If we hit anything, we look at how far through the trace we were, multiply that by our distance of 256, and return that value. So that gives us the distance from our entity to a wall, starting from the offset that we specified up here. So we did that once and save off that distance to a datum called high_dist. We set our trace primitive to trace low, do this dist to wall check again, and save off the value as low_dist. I have these actions here for displaying values of owned data variables to the screen. This is disabled in release builds, so you aren't actually going to see any of that when I launch it from the editor, but in debug builds you would see that displayed on the screen. It would say, you know, the value of high_dist is some floating point value. So now we have these variables called high_dist and low_dist, and these are the distances to a wall in front of us, you know, 8 pixels above the waist and 8 pixels below the waist. So then we get down into the logic of deciding what we want to do based on those. The first thing we do is we have this query tag. It specifies a condition, and the condition is this expression that says high_dist LT is less than high_dist less than 24.0. So this is basically, you know, if high_dist is less than 24. This is how I'm doing like game scripting through XML markup. It's super gross, and at some point I would like to replace this with, you know, a real scripting language. I should probably either, you know, integrate Lua or, you know, roll my own, since I like doing that, even though everyone says not to. But yeah, basically we're asking, is the distance to a wall, you know, 8 pixels above the waist, is that less than 24 pixels? If it is, then we are blocked high. So we stop whatever we're doing. We stop any walk animation that may be playing. We wait for, you know, 0.25 seconds, and then we turn around. And then that behavior would end, and we would go pick another behavior. And right now, the only behavior that's active, I've commented everything else out, so this is the only behavior that's active. So we would go right back to making the same decision. So after we've turned around, we would look and see, you know, are we blocked in this direction? Now, if this high trace, if the distance to a wall in front of us was greater than or equal to 24 pixels, then we consider ourselves to be clear, high. So then we ask, okay, look at the value of, you know, the distance to a wall 8 pixels below the waist. What does that look like? If that is less than 24 pixels, then we're blocked low also. We know that we're clear high, we're blocked low, so we assume that we are standing in front of some short ledge, and we tell ourselves to jump forward. And as I talked about in a previous video, this 1.0 just means that we use our maximum foot speed while we're jumping. We could also set this to 0 and just jump vertically. But yeah, we want to walk forward and jump. We play the jump animation, and then we wait 4 seconds, and, you know, at some point we will land on the ground, and we'll hit this on land event, and that will tell us to choose a new behavior. If our distance to a wall low was greater than or equal to 24 pixels, then we are not blocked high, we're not blocked low, and we know that we can move forward. Now, in a previous version, I basically just said, okay, start walking, and then, you know, keep walking for like, you know, 2 seconds or whatever, and then at some point stop and do something else. But what I want to do now is say, okay, walk forward until you're just about to collide with a wall, and then stop and turn around. So what we do is we calculate this dist to wall again, and this is going to use I guess whatever we set the last trace primitive to, so it's going to use the low value here. We set this to a datum called move dist. This is the distance that we want to move. We decrement this value by 16 pixels, so we know our distance to the wall. We pull that back by 16 pixels. I had been subtracting off another 8 pixels on top of that, but I've commented that for now. Then we walk forward at 100% of our foot speed for that distance. Then we play a walk animation. Then I take the move distance and set that to a datum called wait time. I take my foot speed, and again, this is, if I go to native code here, I have this hard-coded lookup called foot speed that goes to the physics component and looks at what the current foot speed is. I set that to a datum called my foot speed. I divide my wait time, which was the move distance, by foot speed, so now the time that I want to wait before choosing a new behavior is the distance I'm walking divided by the speed that I'm walking. So that will be the duration it will take to reach a point, 16 pixels from the wall. And then I tell it to wait for that duration. So that is a whole lot of really, really ugly markup to do something fairly simple. Just to sort of go through this again, you can see, he's walking, he reaches the ledge, he jumps up there, he walks forward, hits that wall, turns around, he doesn't hit the wall, he stops short of the wall because we told him to move for that distance and then wait for that time before taking another action. And then he turns around and goes back the other way. And because there is only the one behavior for him to choose from, he's just going to keep doing that repeatedly. So that's sort of what I've been working on now. The next step would be add a datum that would be like a Boolean value that would be, is this enemy aware of the player? Has he started pursuing the player? If so, switch out the logic that I run in response to that. But as you can see, this is becoming really, really wordy, and my concern is that I already saw a little bit of this in Super Win the Game, and I've talked in the past, and I've written in my development blog how some of this stuff like this entity tool here. In the past, I had to define animations using markup, and that turned into walls of text itself, and building this entity tool was in response to that, and in wanting to move away from writing lots and lots of markup because it's error prone and it's difficult to read. And I think I'm starting to reach that point now with AI and with these behaviors and with these sorts of actions in general for setting variables and stuff. This doesn't it really wants to be a scripting language, but it doesn't read like a scripting language. And so I've been sort of thinking recently, like, does it make sense to just go ahead and actually try to integrate some sort of a scripting language in here? I'm not yet at that point. Like, I'm not. This is sort of the first time that I've really run into this problem with all this markup for AI, and I'm not yet to the point where I'm like, okay, clearly this is a problem, but it's easy to imagine that by the time I ship Gunmetal Arcadia 0, this will be a problem. So maybe like after 0 and before I start working full time on Gunmetal Arcadia, like maybe that would be a time to look into integrating a scripting language or building my own. But it's definitely something I've been thinking about recently. Yeah, so that's pretty much the extent of what I've been doing recently. As I mentioned before, I was at Retropalooza this last weekend, which was awesome. I'll definitely try to be there again next year. Hopefully, with a demo of either Gunmetal 0 or Gunmetal Arcadia for that show. But yeah, I didn't really have a whole lot of time to work on development stuff this weekend, so pretty much this biped stuff is all that I've done. But I was realizing at Retropalooza, like that was the 11th time that I've demoed Super Win the Game, and like I'm sort of like itching to like demo a new game at some point. So hopefully sometime soon I'll have a public playtest build of Gunmetal Arcadia Zero that I can show off. Hopefully, maybe as I start, you know, um, wrap up some of the enemy prototype work that I've been doing, and I can move on to gray boxing levels and figuring out, a little bit more what sort of player abilities I'll have in that game. I mean, I have most of the sort of core player abilities already implemented, but there are a few things like bomb upgrades that don't really exist in any farm right now. So those will require a little bit of work, and then I'd like to do more with just different weapon types and different secondary weapons and all that stuff. So yeah, and definitely one of my goals is to start getting some sort of playable test build out the door sometime in the next couple of months, but I don't yet know for sure when exactly that would be. As always, if you're enjoying this series, please like and subscribe. You can check out my Patreon page. I have some rewards up there where you can, get a free copy of the game and soundtrack and stuff when it comes out as a thank you for supporting the documentation of this development process through these videos and through my development blog. Huge thank you to everyone who's already supporting me on Patreon. As always, you can send me feedback, either leave comments below this video or, contact me through Twitter or s.fm. My username is Pirate Hearts on both of those. But thank you for watching, and I'll see you next time.